Hello, welcome to Chapter 13, Section 3, where we're going to introduce the unit circle and, even though it's not in the title, we're going to introduce a new way of measuring angles. So previously what we've known, every time we've measured angles, we were talking about these things. See if that one shows up. This is a protractor, and this is used to measure degrees, or angles using degrees. And we can follow this along. We start at 0 and we go 10, 20, 30, 40, 50, 60, 70, 80, 90. We talk about a right angle being 90 degrees, but I don't think that we actually talk about what those numbers actually represent. I mean, why 90? We do lots of things like using like multiples or powers of 10. We have a base 10 system. Why don't we like go from 0 to 100, or why don't we go from like 0 to 50 to 100 all the way? So why is it that we pick 90 for that? Well, just briefly, and we'll talk more about this in class, the idea that if I have from, like if I'm going around like an angle rotation, if I go from 0 to 90 and then to 180, and then I only got one of these, so you have to pretend. Then if I'm at 180, then I go another 90 at 270, and I make it all the way around the circle, that's 360 degrees. Well, where does the 360 come from? It's related to the number of days in a year. I believe it was the ancient Babylonians, when they were studying the sun and the stars and the moon, they believed that the sun was a god, and that the sun god took one step every day as the sun god walked around the earth, making a complete circle in a year. So even though there's 365 days, and sometimes one more for leap year, even though there's that many days in a year, they thought it was 360. So that's where we ended up with. Now, it's a nice number because, again, I can divide it up into, 360 is divisible by a lot of numbers. It's divisible by 2, it's divisible by 4, 3, 5, 6. It's not divisible evenly by 7, but it is by 8, 9, and 10, and a whole bunch of other numbers. So it's a nice number, and it works out. But it causes problems when we try to do some advanced math. We can talk about physics we can talk about calculus, but actually it causes problems when we get into physics if we keep doing everything with degrees. So we have a better way, and the way that we talk, the better way is using something called a radian. And the idea is this: I have a circle, and this distance from the center to the edge of the circle, or to the circle itself, obviously that's called the radius. Whatever that radius is, if I take that same distance and lay it along the curve of the circle to make an arc, this angle that I get right here is about we call it 1 radian. It's not about anything, sorry, it's 1 radian. I was going to say it's about so many degrees. Now, if I figure out what the arc is, and I go all the way around the circle, then that circumference is going to be 2 pi times whatever the radius is. So just to keep things simple, we talk about a circle where the radius equals 1. So then the circumference is just going to be whatever 2 pi is. Well, that distance that we have, that translates into the actual radian degrees. So we say that even though we're talking about the circumference, the angle that represents the circumference, we call it 2 pi radians. So completely around 360 degrees equals 2 pi radians. And a better way of saying, if I divide both sides by 2, 180 degrees equals just pi radians. And normally we don't even say radians. We say it at first just so you know we're talking about radians, but we actually just say the angle measurement is 2 pi, because that assumes that we're talking about radians. If you are, hit clear here. Yep. So I've been working on this one already, but you'll notice that when you reset your calculator, the default setting is radians. So radian measurement is the measurement of choice in upper level math. So right now we're going to talk about converting from degrees to radians and from radians to degrees, going back and forth. To go from degrees to radians, you just multiply by pi over 180. That's the same as 2 pi over 360, but without the factor of 2. Since 180 degrees equals pi radians, so the top is equal to the bottom, the numerator is equal to the denominator. So what I'm going to do, I'm just going to multiply by 1. If I want to go backwards, I'm going to divide by this fraction. And dividing by fraction means multiplying by the reciprocal. So then I'm going to have 180 divided by pi. Okay, so I've got it right down here. This is from degrees to radians, and this is from radians to degrees. So at first we're going to just do it just like a multiplication problem. We're just multiplying fractions. But pretty soon you will get to where you will see these without, you'll make the translation without even thinking about it. All right, so let's do a couple where we go from degrees to radians and from radians to degrees. Negative 45, the negative just means that you're still going clockwise. The direction counterclockwise is positive, clockwise is negative. That's the same as it has been. That's what we learned last section when we talked about angles of rotation. Whether you measured in degrees or radians does not change the direction that you're going. So all I'm going to do is I'm going to convert 45 degrees to radians, and still it's going to be negative because it's going in the negative direction. So I'll write the negative. I don't want you to think it goes away. I'm going to write negative 45 over 1. I can put the degree symbol there if I want. I'm going to multiply by pi over 180 degrees. This is going to give me negative 45 pi over 180. Now, this is where I need to reduce my fraction. And before you start to panic and think, well, this is really, kind of hard. After learning about the like how we divide up the circle, you're going to recognize what fraction this is real quick. So let me grab my protractor again. And again, this is only half of the circle, but I'm looking at from 0 to 180. 45 is 1/4 of the way. So it's 45, 90, 135 right there, and then 180. So you can factor, cancel, remultiply if you want, or maybe you just recognize that this is going to become negative pi over 4. The 45 and the 45 times 4. 45 times 4 equals 180. That's going to reduce. Let's try 80. So same idea, 80, we'll put it over 1. I sometimes don't even put it over 1. You don't have to. Times pi over 180. This is 80 pi over 180. And what's going to reduce? Obviously, I'm going to have a factor of 10 that's going to reduce. And I'm also going to have a factor of 2. So I get 4 pi over 9. For negative 36, again, the negative is going to stay with it. Make that time sign a little bit better. And I get negative 36 pi over 180. And what's going to reduce? Well, looks like I have a common factor of 18. This is 18 times 2, and this is 18 times 10. Oh, it also has a common factor of 36. I just, saying that out loud, I realized there was another. So 36 times 5 equals 180. So this is going to be negative pi over 5. And again, if you want to factor into primes and reduce by canceling common, I know we don't say cancel anymore, but if we want to reduce common factors, that's perfectly okay. All right? So some of these may not necessarily be that obvious. I want to point out this one right here, okay? So again, I'm gonna flip this over. Oh, that's not gonna help. Okay, so maybe you see this even though I'm writing on the printed stuff, okay? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 sets of 10 degrees. And 80 degrees would be 1, 2, 3, 4, 5, 6, 7, 8 of them. So that's 8 over 18, which is going to reduce to 4 over 9. Or you can think of it as like, here's 20, 40, 60, 80. That's 4 groups of 20 degrees, and then I've got 9 groups of 20 degrees, making it all the way to 180. So I think of these things kind of like in fractions of the circle. I don't know if that works all the time. Different people have different learning styles. I'm a visual learner, so I like to think of it in terms of like parts of a circle. But after a while, it'll become like just second nature. You'll just be able to you'll know immediately. Like by the middle of pre-calc next year, you'll know that when somebody says 90 degrees, you'll think pi over 4, okay? Or sorry, if you think 45 degrees, you'll think pi over 4. Just want to make sure I'm saying the right thing. All right, let's convert from radians to degrees. So I'm going to do 5 pi over 6, and this time I'm going to multiply by 180 over pi. And one thing to remember, if I'm going from radians to degrees, the pi, even though I wrote as pi, I didn't write as 3.141592, whatever, I just leave it as pi. The pi's are going to reduce. Those things are going to disappear. So I've got 5 times 180 divided by 6 after I eliminated the pi. Now I can multiply, I can divide, I can look and see what I have here that might be able to be easier to simplify. 180 divided by 6, that's easy, that's 30. So I get 5 times 30, this just becomes 150 degrees. 2 pi over 9 times 180 over pi. Again, the pi's are going to reduce, and I've got 2 times 180 over 9 after I eliminate the pi. Again, you can multiply 2 times 180, you get 360. 360 divided by 9 is going to be 40. Or you can take the 180 divided by 9. That's going to give you 20. 2 times 20 equals 40. Either way, however you want to do it, you're going to get 40 degrees. And finally, 4 pi, I'll put that 4 pi over 1 times 180 over pi. Again, the pi's are going to be eliminated. So pi divided by pi equals 1, so it's going to reduce. So this just becomes 4 times 180. And if you want to multiply that, I believe that that's going to be 720 degrees. So that's the process, but I promise you that you will eventually get to where you can just do this in your head. I promise you'll get there.